Now that we have the basic player, I want to work on the basic movement logic, where we capture player input, we move left and right, and we can jump and fall. For all of these, we are not going to add a proper logic. I guess for now, I just want to have the basics, and we're going to refine things later. For all of this, inside of the player, I want to attach a script to the root node. The defaults, as always, are totally fine. And then, inside of player, I will need a couple of basic variables. I want to have a direction, although this should be direction_x. The player can only move left or right. Up and down is going to be covered by jumping and gravity. So this is going to be a float and nothing else. Other than that, I want to have a var speed, which is going to get a default value of 120, and this should be exported so we can customize it a bit more easily. After that, to actually do some movement, we will need a func physics process in which we update velocity.x. The value is going to be direction x multiplied with the speed. As a reminder, when we're using velocity along with move and slide, we do not need delta. Godot applies that one automatically. Add an underscore here, then Godot gets rid of the warning. Once we have that, we can run the game and nothing is going to happen because we are multiplying 0 with 120. The result is still going to be 0, so this velocity.x is not going to do anything. However, if I set direction.x to a 1, then we should be going to the right, and we do. That looks good. Collisions also work. That's a really good start. Although this value shouldn't be 1, this should be dynamic, for which I want to have another function, func get_input, for which, most importantly, we want to get direction.x and then capture the user input. Since for this one, we only care about one axis, left or right, I want to get input and get axis. You have probably used getVector before, where we are checking 4 different directions, left, right, up, and down. GetAxis is the equivalent for one axis, where we can only check a negative and a positive action, which in our case are going to be left and right. The keyboard input actions that we have defined earlier inside of the input map. These ones here. Or in other words, this is A and D on the keyboard. This function we want to then call before we're getting the velocity. And now I can move left and right quite easily. That works well. Besides that, we have to move on the y-axis, which means we need jumping and gravity. For the gravity for now, I just want to have a basic value, var gravity, and this can be 10, which we then want to apply. Below velocity.x, I want velocity.y plus equal gravity times delta time. And now we do need delta time, so remove the underscore, then this is going to work. Although all of this, we only want to apply if not is on floor. We don't want to increase the y velocity if the player is on the floor. That way, we should at the very least be falling down, which we can see here. So this is working, although a bit slow, but it does work. If you change the gravity to, let's say, 50, this should be more visible. Next attempt. And there we go. We are going to refine this later. For now, don't worry too much about it. More importantly, I want to check inside of getInput if input is action just pressed with jump. On top of that, I want to check and is on floor. We only want to jump if we are on the floor and if the player presses the jump action, which is space on the keyboard. If that is the case, I want to get velocity.y and then set it to some value that has to be negative. Let's say negative 200. If I now press space, we are jumping quite a bit, and at some point we should be falling down again. There we go. We might have to refine those numbers. Let's say for gravity, I want to have 200 and for velocity.y for the jumping, I want to have negative 250. That way, we are getting a more reasonable jump that doesn't feel good. So this we definitely have to refine later on, which is going to be a separate part. For now, I just want to have the basic mechanic, which does work. With the basic player covered, I want to work on the player animations, which means I want to have a walking animation and a jumping animation for the legs. Besides that, the torso should aim at the mouse cursor position. Back inside of Godot, if you look at the player, or more specifically, player.png, the texture. When you look at the torso parts, we have 3 different weapons: the default weapon, a shotgun, and a rocket launcher. For every single weapon, we have the torso pointing in the 8 possible directions. So right, down, bottom left, and so on. From these, we have to select the right animation depending on where the mouse is. If the mouse, for example, is here, to the right of the player should face to the right. If the mouse is here, the torso should be facing up. But let's go through it step by step. First of all, inside of the player's script, I want to create another function, func animation, in which we are first animating the legs and then the torso. The order doesn't really matter. I think the legs just are a little bit easier. First of all, the legs have to point in the right direction. At the moment, by default, they are pointing to the right, but if we are moving left, they should be pointing left. That's an easy thing to add. I want to get the sprites and leg sprite, and then flip h should be direction.x being smaller than 0. That's all we need in here for now. I want to call animation. Also, to keep all of this organized, we can create one more function, func move, in which we are doing all of this, for which we need one parameter, delta, that we are passing through. So before we are animating, I want to have move with delta time. That just feels a lot more organized. If I now, inside of the game, go right and left, the legs are going in the right direction. Although, to refine this, we only want to update this value when the player is moving, because at the moment, if I'm, for example, going left, then stop, then the legs flip back to the right side, which we don't want. To fix that, all we have to do is to only do all of this if direction.x is different from 0. That way, we are only changing flipped if we are moving. If we are standing, we don't touch the value. That feels nicer. Now that we have that part, we have to create the actual animation for the legs, which I want to do via an animation layer. The first animation, so animation and new, is going to be for run. I want to add a new property track where we are getting the leg sprite and targeting the frame. Then zoom in just a bit, and I want to add a key where the first value is value 26. Looks like this if you move across the timeline, and if you go to the leg sprite, we have 26. I want to increase this, and then click on the key. Godot automatically gives you the next value. And we want to go from frame 26 to 32. The distance between each frame should be 0.2 seconds, which means you want to reorganize this, where you have the first frame, frame 26 at 00, then the second one at 0.2, the next one is going to be at 0.4, then we go to 0.6, and then you continue all of this. The duration of the animation is 1.4 seconds, and you want it to look like this, where you have 0.2 seconds between each frame, and then you go, once again, from frame 26 to frame 32. This should continuously play, so enable looping, and then, if you run the entire thing, we are getting a running animation. I guess while we are here, we can also add another animation, so animation new for jump. This one is going to be a property track with the lag sprite, and I want to target the frame once again, for which I will only need a single frame, the one with value 25. If you run this, you get the jumping animation, which should also be looping, and then we have the jumping frame. Finally, we need one more animation, for which we can duplicate the jump animation. So duplicate, the name here should be idle, which is going to work in the same way that jump does. We only want to play a single frame, which is number 24. This one looks like this. With that, we have an animation player that updates the legs, which we can then use inside of animation. I want to get the animation player and set the current animation to run, but only if direction.x. So if we are going left or right, then we should be running. If we are not, else, then this value should be idle. If I now run the entire thing again, the player is going to run once we are moving around. That works pretty well. To expand this for the jump logic, I want to check if is on floor. We only care about these two animations if the player is on the floor. If that is not the case, else, then the animation player, we can copy all of this, should play the jump animation. And with that, I can jump. With the jumping animation, I can go left or right. And if I fall down, we are also jumping. That works reasonably well. Although I think one bit that we do have to fix is that if you look closely, let me increase the camera zoom to 8 and run the entire thing again. If the player goes left or right, we have this gap between the leg and the torso. Just keep that in mind. We'll fix it in just a bit. First of all, though, I do want to have the torso animation, which means, next up, I want to have the torso animation. For that, we need a couple of bits of information. First of all, the most important part, we have to know where the mouse is relative to the torso. So is the mouse to the right, to the left, top or bottom, or any of the diagonal parts? For which, first of all, I want to have a var raw direction. The value here is going to be get local mouse position, a function inbuilt into Godot. If I print the result, a raw direction, and we don't need any of these other functions, that's a bit easier to see. If I now run the project, if the mouse is to the right of the player, we're getting a value like 30 and 0. If I go above the player, we get 0 and negative, let's say negative 40. To the left, we get negative 30 and 0, and you get the idea. By I get local mouse position, this function here, we are getting inside of the player scene the position of the mouse relative to this origin point, which is really all we need. The issue, though, is that this value we can't use right away. First of all, I want to normalize the value. That way, we are capping the length of this vector to a size of 1. If I run the entire thing again, now the maximum value is going to be 1. So if I'm to the right of the player, we're getting roughly 1 and 0. If I'm above the player, we're getting 0 and negative 1, like so, and you get the idea. This value we have to round to get proper nice values that we can work with much more easily. For that, I want to get var adjusted direction. The value for this one is going to be a vector to integer. So the I here stands for integer. Inside of this vector, we only get integers like 1, 2, negative 1, and so on. In a normal vector, we are working with floating point values, which we want to avoid because those values you can't really organize. Now to turn a normal vector 2 into a vector 2 integer, we want to round the values. Raw direction.x for the x values, and then for y, we want to have around raw direction.y. That's all we need in here. If I now print the adjusted direction, I know I am to the right of the player, I am above the player, I am to the top right of the player, and you see where this is going. Now we know very easily where we are in relation to the center of the player. That is much easier to use. How do we turn this value into an animation? Or in other words, the thing that we have to figure out is, if you look at the player graphics, we have to connect a vector 1 and 0, so the mouse is to the right of the player, to this graphic. If the mouse is on the bottom right, we want to get this first image and so on. Meaning we have to connect this direction to an integer that targets the right frame inside of this graphic. And for that, if you look at premade, we have this dictionary for the gun directions. This I want to copy and paste into the player. Like so. And then we have all the information that we need. For example, vector to integer 1 and 0 is going to get the target value of 0. Which means, if the mouse is to the right of the player, we want to get this frame with the index 0. All we need to do is get the torso sprite, and the value we want to assign is gun directions. The dictionary const we have gotten up here, where the value we are picking is the adjusted direction. Also make sure you're getting the torso sprite dot frame. With that, if I move the mouse around, the player torso updates to always target the mouse. And this feels pretty nice. And if I move around, we are still getting a slight gap between the legs and the torso. Although, first of all, this one should be deleted. And now to test things, the camera 2D should zoom in by a factor of 8. Let's try this again. I can still look around. And if I go left or right, then we have a gap between the legs and the torso. To fix that, the leg sprites should get a transform of -7, so they are a bit further up, and the torso sprite should get a Y value of -8. That way, inside of the game, we can move left and right, and this still fits together quite decently. If we zoom out the camera to a factor of 3 again, this is going to look nicer. So I think this still works pretty well. Although in a real game, you might want to update the torso position on every single animation of the legs. That would be a tiny bit cleaner, but for our purposes, I think this still works pretty well. Although we do have to make sure that the collision shape also works with the legs. So you can use the ruler to make sure that those two are aligned. At the moment, we have half a pixel of an offset, for which you want to go to the capsule shape and set the height to 31. That way, these two are lined up much better. Next attempt. Now it looks like the player is actually on the platform. Now that we have the basics set up, we can work on the proper player movement. At the moment, our movement system just isn't very good for 2 reasons. Number 1, the jump fall mechanic just doesn't work out. It feels more like the player is floating rather than falling or jumping. Besides that, the horizontal movement also doesn't feel natural. We either stand still or we move at full speed. There's no in between, which usually does not feel right. To fix that, let's start with the horizontal movement. To fix this part, we need acceleration and friction. The player shouldn't go from 0 to full speed, and then when we stop moving, back to 0. Instead, you want to accelerate to full speed over a short amount of time, and then once we stop, the player should gradually slow down. Let's implement this part first. Back inside of Godot, I want to work in the player script, and at the moment, we are covering all of the movement inside of getInput, where we are getting left and right input, and then inside of move, we are updating the velocity, and then we are calling move and slide. If the player presses left or right, we are changing velocity x to 1 or -1. If we don't press anything, it's going to be 0. There's no in between. That we need to fix, and we don't need input for that. Instead, when we have input, we want to do something. So if direction x, and then I still want to update velocity.x. But now I want to set a different value. And really important in here, I want to move toward a value, which is a function inside of Godot. We need a start value, a target value, and the duration. Our start value is going to be velocity.x. Our target value will be direction x multiplied with the speed. So effectively, this is our target speed. And then we need a duration, which I want to set to acceleration times delta. Acceleration at the moment does not exist. Below speed, I want to export var acceleration. This can be an integer, and I want to set a default value of 600. That way, when we have input, we are always starting from our velocity, and then we are moving towards our top speed. If that is not the case, else, and we have no input, then we want to slow down, which will be another move toward function. Our start value, once again, is going to be our current velocity, or velocity.x, and this is the value we want to set. So velocity.x is going to be move toward. We start with the current value, and now we want to go to 0. Then we need a delta time, which in this case is going to be friction, which I also want to multiply with delta time. So now we have to define friction. Right below acceleration, we want to have friction, which I have set to 800. And then we are done. If I now run the entire thing again, I can go left and right. And I guess for testing purposes, inside of Subway, I want to extend this platform a good bit so we have more space to work with. I want to have a nice and long platform, like so. And now, if I start moving, and you look very closely, we are accelerating and decelerating. If I lower the values to something like 100 and 100 as well, you are going to see this much better. We are accelerating very, very slowly, and at some point reach a top speed. If I stop pressing the button, then it takes quite a while to slow down. With this system, we are more or less moving on ice, which doesn't feel right. So I want to return to 800 and 600, which feels better. Although play around with these numbers can be a good way to experiment. Besides that, I want to work on jumping and falling, for which we are going to need some projectile math for a nice system. We want to control how fast the player jumps and falls. Those can be two different values. Very often, you want to have a faster fall than a jump. It just feels nicer. Now, I won't cover the math in too much detail, but if you're interested, there are two excellent YouTube videos on it. They are called Making a Jump You Can Actually Use in Godot by P. Fieper and Math for Game Programmers Building a Better Jump. I am primarily going to rely on the first video. I'm basically using his math entirely. In fact, back inside of Godot, if you look at Premade, this link leads you to his video, and these formulas were written by him. To use them, I want to copy all of them and paste them inside of the player's script, like so. At the moment, when we are jumping, the jump is very, very slow, and it feels kind of like we are floating. It's just not natural whatsoever. That we can fix with these values. And fundamentally, we are simply setting 3 values, all of which are floats. And then we are using some basic projectile math to calculate how fast the player is jumping, what the gravity is when we are jumping, and what the gravity is when we are falling. First of all, to use that, we have to use the jump velocity instead of the velocity we have used when we are pressing jump. This -250 should be the jump velocity. Then we have to figure out which gravity to use, for which I want to have another function called funcGetCustomGravity. No need for parameters. All we want to do in here is to return the jump gravity if velocity.y is smaller than 0.0. If that is the case, we are going up, so we want to use the jump gravity. However, if we're going down, else we want to use the fall gravity. Also, from this function, we are returning a float. After we have that, we have to apply one of these two values, which we're doing inside of move, where we are adding the gravity. But now, we don't want to have the gravity, we want to get our custom gravity. Don't forget, you still need to multiply this with delta time, so you account for different frame rates. But other than that, now we are getting a much nicer jump. It feels a lot snappier, and I think this is a pretty good system. And if you want to customize it, you just have to change these values. For example, if you want to jump higher, set this to 200, and now we are jumping twice as high. But other than that, we are still working with a very snappy jump mechanic. I think 100 here is fine, but once again, play around and see what you like. Depending on the platformer that you want, different numbers are required. We don't need this gravity anymore. And if you want to be super organized, you could export a category where we have jump and we have, let's call it move. With these tags, if you look at the player, this one here, we're getting a move mechanic with speed, acceleration, and friction, and we get a jump height, jump time to peak, and a jump time to descend. Makes the entire thing just a bit more organized.